Thanks, Ben. Well, that's that's a bit of an introduction. But I guess we're Eurobuild. I run this small architectural practice. We have some in-house engineers, and our specialism is low energy and passive house, as you've probably heard. I'm going to talk about sort of 5 broad things. I've only got a small amount of time, so I'm going to hit you really hard with about 30 slides. We're going to talk about Hadlow College, which is a new build. I'm going to talk about large residential, commercial and small resi, more about point cloud and use of point cloud BIM, and then small residential, and then intelligent objects, which could be seen as BIM level 3. I think that's, but we'll come on to what I see as BIM level 3. This is what I get asked to talk about a lot. I try not to talk about it anymore, but it still gets talked about. It was built in 2010. It's a passive house educational building. It's certified. It's a small building, so it's only a £500,000 project. I talk about this a lot. This is July 21st, designed and built in ArchiCAD, just the shading, very important component, part of passive house design, and then July 21st in reality, and you can see the precision and the importance of shading. Construction rehearsal, so this we did in-house because we were unusual. We're an architectural practice that's insured to build up to 5 million. So this was in 2007. We used the tool to rehearse building, and so putting a crane on site, we had 5 lorries arriving and a set of panels that all had certain characteristics. Due to this construction rehearsal, I like to think, we were able to build the building in 3 days and achieved 15 times better than building regs airtightness standards, and obviously got certified as a passive house. This gets spun about a bit as well. We work with a mechanical engineer who provided us with 2D drawings. We took the risk and took his drawings, took them into 3D. That took about a day and a half. But what did that do for us? Well, as construction management, that massively reduced our risk, and we had all of the apertures pre-made in the fabric. That meant the ductors who were meant to be in for 4 days, thought they'd be in for 4 days, were in and out in 2.5. But it also meant we knew how the building worked, which was pretty good. Does it work? So this is after 3 years of data. A typical school in the UK for heating and hot water, after a survey of 834 schools, uses about 133 kilowatt hours per metre squared per year. Hadlow's using 26, which is about 80% energy reduction. And the same in electricity, 48 to 70% energy use. And does that come at a premium? No, it doesn't. We built it at 1742, all inclusive, all the costs per square metre. That's a 15% less. So it's not just for a premium. We'll talk about Enefit, which is the passive house refurbishment standard. Quite a bit bigger contract, it's a £15 million contract that we're appointed architects and M&E coordination. So it's a big house in Chelsea. Existing and proposed. There's a 50% space increase from what we've designed. It doesn't look like much of a space increase here. That's because we go underground as well in the garden. And Kensington and Chelsea are just stopping these because these allegedly iceberg developments, because various residents are concerned that there's too many of them. The only reason we were brought in is because the Grade 2 listed building, can't just strap PV to it or external insulation and hope for the best. We're specialists in internal insulation and modelling that and making sure that you don't get any interstitial condensation. But we're also specialists at achieving very good energy ratings for BREEAM. And in order to get an iceberg development now, you have to achieve BREEAM excellent. So that's what we do. Some of the keener-eyed of you will be seeing electrical sockets. We work with mechanical electrical engineers who work in DDS CAD. So we work collaboratively in teamwork. We have one model in the cloud and various consultants working within that already. So just showing some of the ventilation. Obviously, one of the key pillars of passive houses, mechanical ventilation with heat recovery, and this is throughout the house. And we are achieving, despite the 50% space increase, an 80% energy reduction. This is just to compare some of the stuff that we do in passive house. This is Hadlow College, and it's showing on the same scale the type of heat loss that's going on. This is a pre-survey, so before we started knocking down the extension of this Grade 2 listed building, how much heat is being lost through a Victorian house and what we actually have to deal with. So I like pointing out this die-cast soil pipe, which is sucking the heat out of the building. In ArchiCAD, using BIM in in a sustainable way. Just this is how the renovation tool works. Yellow, what we're demolishing, what it looks like when it's demolished. Green, what's new, what it looks like when it's new, and this odd thing that we call status combined, which looks like a mess, but it's extraordinarily useful in design because you can find out what's happening, what's new, and what isn't. But it looks like a mess right there. But I'm just telling you it's useful. How do we model? We developed a way of working. We use 3 tools for energy modeling. That's the PHPP, TAS, and this internal tool within ArchiCAD, which is called Eco Designer. This is called Eco Designer Star, which is very more accurate than Eco Designer. We can assess, split up the building by internal volumes, internal spaces, and model each space. We can look at thermal bridges. We look at thermal bridge in other programs as well, in Therm and Delphine. So there is a thoroughness to our process, I guess. And as a result, what might typically use £50,000 of energy a year is predicted to use in the region of £8,000. Something around this basement, the fabric is key, and we've developed new details, and it's quite a difficult dig, so it's a 12-metre dig, 2.5 story, and very difficult thermal bridges in the main house that we're dealing with. Lots of different wall, floor, roof build-ups. Couldn't do this without BIM. Doing it in Vectorworks 7 years ago, not a chance. This has got serious implications for only 2D workers, and we've been hitting this all along with the other consultants, that we couldn't do this without BIM, without ArchiCAD. Lots of complexity and structural enhancement within the main building. More refurbishment work to passive house standard. We just got planning permission for this in a national park, so a refurbishment of a stable block, very small project, but interestingly, the use of point cloud. We surveyed using point cloud, and so this is basically a camera taking lots of different points in space, and then we used that tool with a normal surveyor to give us 2D plans, and worked with this point cloud to confirm everything that we build in 3D, and that's been brilliant. It's not new in the industry, but it's new to us, and it's coming along. Why is it coming along? Why is it helpful? Well, now we built this building in London, 5-story commercial office building. We built it in 2 days in CAD. So we know everything about the building, and if we missed anything, we can go back to it, and that's been absolutely invaluable. Last bit then, I want to talk about a slightly less glamorous project, which is a passive house refurbishment, Victorian Terrace, for a TV presenter. Got planning permission, so it's not a 4-year project. It's an 8-month project, and we've completed it. So a standard Victorian terrace. Again, couldn't do this without BIM, and probably couldn't achieve the results we need to through passive house without BIM. So this is kind of standard 3D sections that help us understand what's going on in the building. We build the building thoroughly each time, and a lot of people say, why do you bother? Why do you bother going into such detail? You don't need every joist. Well, actually, every time we do it with every joist, it pays back dividends. At some point in the project, it's absolutely invaluable. It's a pretty tight site. We really used the garden. Again, back to construction rehearsal, making sure the steel works, how you're actually going to build it. ensure the contractors know what they're up to. Mechanical ventilation, we model mechanical ventilation. It's not even our job, but at least we know it's not going to impact on the space. And even if it's not built exactly like this, we've covered a lot of the problems before we get to site. So existing Victorian terrace mess, in construction using porotherm blocks, so T8 porotherm with pre-insulated clay blocks and brick slip system as built. Again, probably standard details, but very easy to work in BIM as a result. And that's the porotherm block I'm talking about. That's the brick skin. It's not crazy, but it's not a crazy hippie horsehair shirt house. It's a very normal house, and they're living normally, and they're loving it. And monitoring, 3 months use, 2 months without any heating on at all. Didn't turn the boiler on. They didn't know the boiler wasn't on, but they had free hot water for a year. And British Gas are predicting £4 per quarter, so it's about £3 a month if you take out the. So, and that's over 3 months in autumn in a Victorian building. Last bit then, BIM level 3. I think I've got a bit enough time. How long will we go? Yeah. Okay. Thanks. So we work with. I was talking a little bit about refurbishment. Going back to the start, talking about new build. We are partnered with a factory in Austria. This factory here, it's also built to passive house standards. So it's heated by the compressor and the saws, and very efficient. It's very efficiently laid out. With them, we've helped to deliver over 400 passive house buildings, most of them in Austria. It's a timber frame factory. It produces an envelope, and the envelope's very well refined in terms of achieving U values and air tightness required. What did we do? What have we done with a university and knowledge transfer network and TSB funding? We felt there was another opportunity here with BIM, and we'd like to work with architects. We already work with other architects, and we have developed a panel. And our panel system, both roof, walls and floors, have within them I-beams, and we developed a BIM product, really, an object that other architects can download as objects and use, that are already pre-configured for use. And for instance, if you make the panel bigger as you're making your building in ArchiCAD, it's intelligent enough to optimize the right level of I-beam within that panel, and it's calculated according to engineering standards, and that's Eurocode 5. So it means that within the panel it's insulated as well, and the junctions are all calculated, and it makes architects' jobs much easier in achieving passive house. And so we also thought about level of detail, protocol support, what it looks like at 1 to 50 as opposed to 1 to 100. You don't need all of that detail. And then what happens in 3D? Does it give you everything you need? Yes, it does. How does it work on site? We also gave it different component finishes, which are all achievable through the factory and in the UK. We also did a work for a BRE competition. We came second in the passive house competition, national competition. We came second in theory because the structure came from Austria. But as part of that competition, we had to do a life cycle analysis of our structure, and we showed that our structure is lower in embodied energy than anything made in the UK, even in timber frame. And we compared it with a masonry structure as well. How's that useful? Well, we pulled all of that information in and built it into our object as well. And we can now build a building with our sophisticated BIM object in ArchiCAD, press a schedule button, and know exactly the embodied energy, the weight, important for transport, volume, important for transport, weight also important for craneage, size of it, and the cost. So we can get the cost, LCA, it's all in there. So architects can already work with our panel effectively send the building to us and we'll get it built in a factory and bring it over. So why is this important? I'm not talking about solar panels, not about anything that's traditionally thought of as sustainable. Fabric is the key, and resource efficiency of fabric, and I guess these 5 lines for us really represent what BIM and sustainability in BIM is. There's less checking, it's an easy output, really quick and real. Every section you do, we don't draw anything anymore, we build. And if you need a drawing, you cut the building up. This drives a greater understanding of buildings. This means less time later on. Less risk for the same effort, and good value for less effort. 2 different things, but very similar. I think my time's up. Thanks a lot.
Thank you, James. We're now back on track.